Hey Bears, this is Miss Madden, and we are going to start talking about concentration and how to calculate it. I want to keep this short and sweet, so let's get to it. Today we will investigate molarity so that we can understand the relationship between moles divided by volume. To some degree, you already understand what molarity is. Another word for molarity is concentration. It's how concentrated a solution is. If I have a cup of coffee and I put half a packet of sugar in it, right? There's a relationship between the solute, which is the sugar, and the solvent, which is the coffee. Now, the more sugar I add, the higher the concentration of the sugar, the sweeter it's going to taste. So, to summarize, molarity is basically the amount of solute to solvent, or per solvent. In chemistry, we can actually calculate molarity. Molarity is equal to the moles of solute divided by the liters of a solution. When calculating molarity, when looking very specifically at a couple of things, first of all, our solute has to be in moles, and we're going to run into some problems where we're not given moles, we are actually given mass. And so just to quickly review, moles is equal to the grams that is given, whatever they give you in the problem, divided by molar mass. Remember, molar mass is when we take the mass of every single element in a chemical formula and add them together. Another conversion that we might end up running into in these problems has to do with our volume. Our volume very specifically has to be in liters. Sometimes we might actually be given our volume in milliliters. And so one conversion that we might end up having to do, or that you need to know, is that there are 1,000, sorry for my writing, there are 1,000 milliliters for every 1 liter. So let's take a look at our sample problem. It says, find the molarity of a solution containing 0.788 moles of magnesium chloride and 0.250 liters of water. All right, so we see that our problem is set up. We're solving for concentration or molarity. It's the same, means the same thing. So we set up our problem. Again, our formula for molarity is equal to capital M is equal to moles divided by liters. And so our problem is set up with our moles, our 0.788 moles of magnesium chloride, divided by 0.250 liters, which is the total amount of our solution that we're trying to solve for. I strongly suggest that you look into either getting some sort of app or something. All you need is a simple, basic scientific calculator for this. And so when I inserted, let's see, whoops, came out way too big. When I put in 0.788 divided by 0.25, I got back the answer right here, 3.152. So 3.152 is my concentration for this solution, and the unit that I use for concentration is capital M. Okay, so here's an example of a slightly more complex problem. We're not given specifically the moles or the liters, so we have to convert both of them before we can plug it into our molarity formula. So let's take a look at this. Find the concentration, aka molarity, of a solution made by adding 437.4 grams, notice it says grams, it's not moles, of hydrochloric acid to 1,000 milliliters of water. So I'm underlining my mass. I'm going to box my volume just to try to help me keep my units in order. And we're going to start first by converting, and we have to convert because again, to solve for concentration, to solve for molarity, we have to take moles divided by liters. But our problem didn't give us moles, it gave us mass, and then on top of that gives us milliliters. So let's start with our conversion of our mass to moles. And we've done this before. We've spent a lot of time doing this, and I know you're going to become experts after all this. So, excuse me, to convert mass to moles, we have to take the mass it gives us and divide it by the molar mass. So the very first thing we need to calculate is our molar mass of hydrochloric acid. Now, if we have the periodic table, and you can't see these masses on here too well, I apologize for that. But HCl, we have hydrogen over here, and I'm sure you know by now that hydrogen we typically round to 1.01 grams. We have only one hydrogen in our formula. And then the second element that we have is chlorine over here. And it's kind of hard to see, but it's 35.45 grams for chlorine. So 35.45 grams for chlorine. And we have only one. So we just need to add these together. We have 64.63. So our total mass for hydrochloric acid is 36.46 grams per mole. And we're going to plug this into our problem over here where we're converting 36.46 grams of hydrochloric acid is equal to 1 mole of hydrochloric acid. All right, so when I put that in my calculator, I end up with, let's see, it's going to end up all big again. Give me a second. We end up with the answer being 11.9967087 da 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 da. We're going to round that 11.996 to 12. So we have 12 moles of hydrochloric acid. I'm going to box that because we're not quite done with our problem. We still have more that we have to do here. Okay, so that was for our moles. Now, getting back to the volume, it gave us 1,000 milliliters of water. I can't use milliliters in my problem for molarity. This volume has to be in liters. So we already said that there are 1,000 milliliters for every 1 liter. And this is a pretty simple problem. The thousands cancel out. we're left with 1. So we have 1 liter is our volume of our solution. So I'm going to box that. Now we have solved for our moles. We have our volume in liters. We can now plug this in to our problem to solve for concentration. So we're solving for concentration. M is going to equal our moles on top. We have 12 moles. So 12 moles of hydrochloric acid divided by, we calculated our volume, which needs to be in liters, to be 1 liter. So we're going to put 1 liter on the bottom. And again, relatively simple answer we should get here. 12 divided by 1, our M is equal to 12. And again, our unit for concentration, or aka molarity, is capital M. That's our answer. So just to recap what we talked about today, I introduced to you molarity, which is also known as concentration, which is the amount of solute per solvent. Our formula for molarity is moles divided by liters. Remember, if it gives us mass like it did in this problem, we have to convert to moles by taking the mass divided by the molar mass. Our example right here. And if our volume it gives us is in milliliters, we have to convert milliliters to liters. There are 1,000 milliliters per liter. And then we plug those answers into our problem, moles divided by liters, and we are able to calculate our concentration of our solution. Thanks, guys. Make sure you took some notes. Go back and write down write down what you need to. And we're going to be spending the next few days, or the next day for sure. Tomorrow you'll get more practice. And then we will be talking Wednesday about dilutions. Take care, guys.